welcome to the 7th podcast where I'm going to try to explain the paradoxes that I introduced in the previous podcast. A small correction from before. I realised I was an idiot when I called both my paradoxes Paradox 1 in the last podcast. This was, of course, supposed to be Paradox 2. I hope that didn't confuse too many people out there. So we're on to Paradoxes Explained. The other thing I want to say, which I should have said in the previous podcast, is I'm kind of operating on the assumption here that it's going to be better the way I'm using this format, using a digital screen. But if, you look at it and you're like, actually, we loved Old Man Harkness's handwriting and that portrait orientation, well, we really miss that and we want it back, then, you just let me know. I can make things happen. Anyway, let's get into it. So, with regard to our first paradox, which is the who's really sure paradox. So, remember that we said we had these maintenance men who they were going to put up these walls at either end of the tunnel when the train went in, and it would not cause any problem for the train from their point of view because the train is so much smaller. And then they were going to sort of very quickly at the same time just remove them both like that, so that then as the train moved forward it would not have any issues. That doesn't work. It would just move forward and come out with no problem. But then from the train's point of view, we said that in its case, it measured itself to be much longer than the length of the tunnel. So if there's two maintenance men, they're putting walls up at either end of the tunnel, then it's not going to fit and it's going to crash and cause all sorts of havoc. So how do we address this? Well, I think we all agree that from the frame of reference of the maintenance men and the tunnel, we could fit the train in, so there shouldn't be a problem there. So let's think about from the train's point of view. So from the train's point of view, or from the train's reference frame, really, I should say. So I'm just going to make the tunnel smaller. And I'm going to make the train bigger again. Okay, and I think we can just do away with the wheels. You guys are imaginative enough to not need those wheels. So we're now moving into the train's reference frame. Okay, so what we have happen, I'm going to get rid of this as well just for simplicity. So our train is coming through like this, moving from left to right. It all comes back to the thing that I've been saying to you guys many times, which is every part of special relativity really can be explained with the idea of the simultaneity of relativity. So this paradox relied on the idea that our two maintenance men set up these walls at the same time. But these two events, we should be starting to realise now, are only simultaneous in a certain reference frame. So the situation is very similar to when we have the flashes of light that I've spoken about before. So you remember that I'm just going to use yellow, we kind of had a flash when the front of the train passed the front of the platform, and we had a different flash over here when the back of the train passed the back of the platform. And from the platform's frame of reference, those two events occurred at the same time. But from the train's frame of reference, the yellow event, in this case, would have occurred before the green event. Remember our general rule that the event that it's moving towards will appear to happen earlier, or will be measured to happen earlier. So what does that mean with regard to our walls? Well, it means that our train... Okay, so our train, it enters the tunnel like this, and once the front of the train is in the tunnel, at that point, we would have one of our mischievous maintenance men set up the wall. But this wall is not set up yet because this event is not occurring simultaneously according to the frame of reference of the train. So then the train continues to move, it continues to move. If I can grab it, it continues to move. And then, before it gets to the end, if I can grab this, the maintenance man removes that one. All before the train continues to move out of the platform until the back of the train is now within the platform, and the other maintenance man at the back of the platform, he then mischievously puts up this wall or barrier, and the train continues to move its way out, causing no problems. The maintenance men in the frame of reference of the tunnel, they thought they put the barriers up at the same time, but according to the train, they did not go up at the same time. The front went up and down again, allowing the train to pass through the front, and then the back went up and down again after the back of the train had passed through. So in both frames of reference, we don't get destruction, we don't get the train crashing, and we don't get injuries. So our results at the end are consistent from these two people's points of view, even though they take different measurements about the length of the train itself. So we've resolved that paradox, I hope. In my haste, I misspelled train. I'm going really well. Okay, for the twin paradox, I think that this paradox is so well covered on the internet that I'm actually not really going to go into detail to try and explain this one. So you might know Physics Girl. She has a channel on YouTube, and I think that in general she's great, and this is the website or a shortened URL to get to her YouTube clip to explain the twin paradox. There's also Minute Physics, and so here's the link for that, or the shortened URL for that. Now, you'll see that I've written slightly incorrect here, so I'm just going to very quickly give my overview of what happens in this paradox. We spoke about these two people saying the other clock was ticking slower, but of course by the time one of them comes back, they can't both say the other one is younger. That doesn't make sense. So we just need to go back to something that you might have overlooked when I brought this up, which is that these two frames of reference are not both inertial frames of reference for the entire journey. And remember that Einstein's first postulate is that the laws of physics are the same in all inertial reference frames. So that's fine while the spaceship's going one way, but it must decelerate and then accelerate again for this twin to be able to turn around and come back to Earth. Now, in that period, she would be experiencing some serious forces as that deceleration occurs, and basically the laws of physics in her frame of reference do change in that time. In other words, if she was trying to eat dinner with her tray table open like you do on a plane, it's going to be a bit like trying to eat your dinner on a plane while the plane's landing. It's going to be very difficult. Things are going to fly forward and move around the place. So, therefore, we cannot say both frames of reference are sort of equally valid for taking measurements then, in that sense. So there's a disparity, which is why we get a difference, and we're able to explain the fact that overall one of them will age more than the other. Now, I said here, the Physics Girl one is slightly incorrect. She talks about requiring general relativity to be able to address this acceleration. It's actually not quite true. It can be addressed through special relativity, but just needing to understand that the frame of reference is no longer inertial. But it is an important point, but given that you guys are not examined on this stuff, it's more just an interesting idea. You can really just sum it up by saying the two frames of reference are not both inertial. One is inertial, the Earth, and the other, the spaceship, is not inertial. So we can't say that both measurements, the laws of physics in both are the same, which is why we get a disparity. The Minute Physics YouTube clip sort of addresses it a bit more properly in that sense, but it's also a bit more confusing and much shorter. So it's a very quick explanation. And then this final one is a website, not a YouTube clip, and it explains it in the most thorough form, but it's also probably the most complicated. But if you're interested, take a look at that. But basically what will happen, because like I said, the spaceship is not inertial, that is the one that will age less, and we'll find when she comes back that her twin is a grandma and she is still a young woman. So that's the end of our paradoxes. I hope you've enjoyed it. Our next one we'll look at the lifetime of muons.